Hello, this is Elif Öztürk. In this video, we are gonna answer these books. The name is Preparing to Teach Mathematics with Technology, Chapter 5 questions. Let's first of all, I would apologize to you because I can't access my online books. That's why. First of all, I'm gonna read the questions from the book, and then I will answer it. Okay, let's start with question 1. The question 1 says that let's consider translating ABC triangle by DE line. With this snap point option still enabled in the grab menu. Use the point tool to place a point at 1 and 3 and a point at 1, 6. Label the points D and E. Measure the coordinates of points D and E. Describe what will happen to triangle ABC when you translate it by the line of DE. Okay, let's open the sketch and then let's make it define coordinates. We need ABC triangle. First of all, I think I need a certain point, snap point, such as flat points. Yes, my points are 9, minus 9, the other is 0, axis is 0, great, and the other one minus 5, 0, minus 5, 0, and the point C minus 7, 3, minus 7 and 3. Okay, let's make a triangle. Connect these points and then label with A. Now this must be C from the book. C, AB, A and B. Yes, and then I need the line of DE, which is, I need the snap point again. We 1, 2, 1 and 2, and which is the point D. The other one 1, 6, which is point E, and then I need to connect it. Yes, this is D and E, and let's find the coordinates of these points. This is C, this is A, which is B, and point E coordinates yes, I found all of them. The question says that I need to translate ABC triangle by the line of DE. First of all, I need to mark it as a vector and then pick the triangle and then translate. Yes, translate the ABC triangle by the line of DE, and then I got it, and let's label this one like this, and then I need to also find the coordinates of this. I know I pick the x-axis by my mistake, but anyway, it doesn't really important. It can be there. Coordinates A, and this is B. Yes. Okay. What was the question says that I translated the triangle ABC by the line of DE, and as the question says that I placed a point 1 to 3 and the point 1 to 6, and then I labeled them. Yes, I answered the question 1. Let's go to the question 2. Explain what will happen to the coordinates of the vertices of the triangle. When I translated the triangle ABC by the line of DE, there will be another triangle which points are A, this one, -9 to -4, and this point is -5, -4, and the C1 -7 to -1. Question 3. Mark the line of DE as a vector. Translated ABC. The image will appear. Yes, I got it already. Label the image and find the coordinates. Yes, I also found it already. Describe how the coordinates of the vector and the coordinates of the original and image triangles are related. And as you see that I marked the line of DE and then I translated triangle, and I got a new triangle below the triangle ABC, and the coordinates also you see there. The points are related to each other, which is we can say if you wanted to get the triangle, this one, the image one, the y coordinates -4, we need to go down. Question 4. Drag a vertex of a triangle ABC. Is the relationship still true? Explain. As the question says that I translated using a vector VE. Yes, I marked it, and then it was vertical. Drag the head of the line of the DE, and I call it the head of vector, and then I noticed that the coordinates of the image did change, and I dragged it, and then again I translated this one. Yes, I got the same things. That's I got the original triangle. Question. This also we can say the size and the area of the triangle are still the same. Question 5. In this example, we translated using a vector that was vertical. Using the head of or the tail of DE, and notice how that affects the coordinates of the image of the triangle. Is the relationship you described in question 3 still true? Why or why not? I think I translated using a vector that was vertical, and then I dragged the head, such as I call it E as a head, and then marked it, mark a center. Again, let's translate, and from DE, or do the same things as a D, and then pick the triangle, translate, Yes, in that time also I got the same triangle. Question 6. If point D has coordinates FG and a point E has coordinates HI, describe how you could use the coordinates to write a system of equations representing a translation. D coordinates FG and the points E's coordinates HI. And if I want to write equation of representing a translation, I think it will be the x-axis coordinates will be f plus h, and for y-axis it's gonna be g plus I. Question 7. Does it matter whether you subtract f from h or h from f? Explain. It's matter whether I subtract from f from h or h from I, h from f, because it shows that where is the head or the tail, that mean the way or the direct, we can say. Question 8. Rather than write 3 different sets of equations, one for each of the 3 vertices, textbook will often arrange the coordinates of the vertices into the matrix. Let's open my answers, which is to show as easily. Like, first of all, this first matrix means that where triangle translates that the first row means that y-axis, then the second one shows that y-axis. The second matrix shows that the point of the triangle, which the first row shows that the axis, and second one shows that the y-axis. The sum of these equations in this translated triangle's coordinates, which is the first row, represents the x-axis and the second row represents y-axis, and as you see that. Yay. Question 9. Consider points E, F, G, H and the image E üssü, F üssü, G üssü and H üssü. Describe the translation vector that was used to map points to image points. Represent the translation using matrices. I will show this question's answer with my word. And as you see that there is the points of E, G, F and H, and I wrote all of them as a matrix in the matrix. And as you see that E minus 4 4, F minus 1 1, and G minus 6 minus 5, and H minus 8 minus 1. Yes, the other points are E üssü 0 1 and F üssü 3 minus 2 and G üssü minus 2 minus 8 and H üssü minus 4 minus 4, and this is the translation matrices, which is minus 4 minus 3 4 minus 3. Yes, the points is 4 minus 3, and this is representing by matrix. Yes. The question 10. Created a second equation using matrices that maps the image points E üssü, F üssü, G üssü and H üssü to prepare image points E, F, G and H. How is equation related to question 9? And this is the other way. If the image points F üssü, E üssü, F üssü, G üssü and H üssü are the pre-image points are E, F, G and H in the matrix equation, the matrices place should change, as you see that the below I showed by matrices. and it's related to question 9, which is just the points place is different, which is connecting by the direction of vector. Question 11. A student asks why the matrices are added when you are translating and wants to know whether you can always add two matrices together. Provide an explanation. If the student asks me about why matrices are added when we are translating, I would answer the question, yes, we should always use the addition. On the other hand, if the student sees the subtraction with two matrices, that means the direction are different, but it's still the addition. Question 12. One student sets up her equation and switches the order of the transformation matrix and pre-image matrix. She wants to know whether this equation is equivalent to the matrix equation shown in the book and whether you could always do this. How would you respond to this student? Question 12. It doesn't matter the place of the matrices if we sum of the matrices in equation, which means translating. We do always this one. It doesn't show just the book. And this is generation of the translation rule. Question 13. Drag the head of and tail of the vector and notice how the matrices equations change. What do you notice about the relationship between the head and tail of the vector when the values in transformation matrix are all positive? What do you notice about the relationship between the head and the tail of the vector when the values in the transformation matrix are all negative? Explain why this makes sense. And I dragged it, the head and the tail, and head and the tail, and the vector, and then translating. Translate E to F. Yes, I got this one. What about this one? To as a vector, and again pick the triangle and then translate D to the E. Yay, I got the other triangle, which is when I accept the E as a head, and then translate the triangle ABC, I got this triangle, and let's see again. The vector. No, I made a mistake. I pick this one as a vector, and then pick the triangle and translate from E to D. Yes, I got this triangle, and if I marked D as a head and then translate it, no, marked as a vector, and then pick the triangle and translate. Yes, from D to E, and I got this triangle. It shows the way of a triangle. Question 14. Drag a vertex of the pre-image equilateral. Explain what changes in the matrix equation. When I drag the pre-image point H, I saw the second matrix second number of the column was changing. Also the place of H üssü was changing too. Question 15. Drag a vertex of pre-image quadrilateral. Explain what changes in the matrix equation. This one, it says that A, F, G, H. Its translation vector is applied to the pentagon. The matrix equations will change. And pentagon has 5 points, and the second matrix must have 5 columns, which the fifth column represents the fifth point. According to the pentagon's matrix, the vectors matrix must have 5 columns. Then we got the 5 column matrix. 1, 2, 3, 4. It has 4, but for the pentagon matrices, it must have 5 columns. Question 17. Describe other questions you could pose to high school students using the sketch translation matrices GCP. Let's find this special translation matrices. Translation, yes, matrices, yes. Here it is. And yeah, it says that describe other questions you could pose to high school students using the sketch translation matrices. If I want to ask more questions to my students, I would ask them questions. Place the vector the points are 3, minus 1 as a D, and E 0, 3, and translate it to quadrilaterals by E. Yes, if I write there, which one? D as a, where is D? It represents D3. They can do that. Let's find the coordinates of D and E. This is D. And I will ask them, translate these quadrilaterals by DE. The DE can be minus 11 to minus 4, E minus 11 and 0. And then when I want ask them to change the coordinates of E, and then as you see that the translation of like we call it pre-image, image, and the place of image are changing. The question B can be write the equation of representation of translation. Yes, I want to ask them. Question 18. Question 18. Predict what the coordinates of the image of points A, B, C, and D will be when the stick figure is reflected over the y-axis. Close it, this sketch, and then anyway, let's make it. I need the denser reflection. Denser reflection. It wants from me, here it is, to reflect it over y-axis, big as a mirror, and then reflect it. Yay, I got another stick figure. It wants me to predict these points. Let's label A üssü, B üssü, D üssü, and not this one, C üssü. Yay. I wanna predict them as a it seems that 3, 1 to 3 to 1, B x1 to 10 to 3, D üssü 2 to minus 3, and C can be 9 minus 6. Yes. And after find the coordinates of them, A as a 3 to 1, B 10 to 3, and D 2 minus 3, and C 9 minus 6. I think all of them were true. After found the coordinates of these points. Question 220. No, question 19. Mark the y-axis as a mirror line and reflect the stick figure over the y-axis. Measure the coordinates of A üssü, B üssü, C üssü, and D üssü. Was your prediction correct? Describe how your coordinates of points A, B, C, and D are points A üssü, B üssü, C üssü, and D üssü are related to each other. Explain how the relationship is connected to the reflection over the y-axis. I reflected the stick figure, then I got another stick figure, as you see that, and this is per image and this one is image, we call it. And my prediction is correct. I knew because the distance of the y-axis of the prediction must be same for the image. Question 20. Predict and check what happens to the coordinates when the stick figure is reflected over x-axis. And let's pick x-axis as a mirror and then reflect it. Yay, I got another stick figure, and I think let's label this one C üssü, D üssü, and A üssü, and B üssü. And yes, let's predict the B can be minus 10 to minus 3, and then let's find the coordinates minus 10 to minus 3. Yes, that's right. And A üssü, first of all, minus 3 to minus 1. Minus 3 to minus 1. Yes, it's also correct. What about the üssü? First of all, prediction. Minus 2, 3. Minus 2, 3. And the last one. Yay, minus 9 and 6. I got it. Yes, all of my predictions are correct. Question 21. Solve two systems of equation to show how to solution A equals minus 1, B equals 0, C equals 0, and D equals 1 were found. I want to show my answer, how I solve the questions 21, and I made it A, B, C, D as a question says that A minus 1, B 0, C 0, and D equals 1, and X, Y, and I got minus X and Y, and X equals 0, Y equals 0, I got, and as an equation. Question 22. Open the sketch reflection matrices. Reflection matrices. Okay. And in this sketch you will see the coordinates of the vertices of an original triangle and the coordinates of their image. Consider different values of transformation matrices matrix T shown in item A to D below. Describe the effect of multiplying each of these matrices by the matrix containing the coordinates of the equals points. Drag a point and determine the transformation that was applied. It wants from me for A, I need to write there 1, 0, 0, and it must be 1 there. Yay. And I got the same triangle. What about B? 1, 0. It reflected over itself for A. And if I write there -1, as you see that it reflected over the x-axis. What about C? It wants me made there positive and made it negative. As you see that it reflected to the y-axis. And the last one, D, wants me to made it there 0, 1, 1, and 0. Yes, as you see that it reflected as a x equals y equation. Question 23. Consider the matrix 1, this one as a 1. If I wrote there, right there 0, and 0, I made mistake, and 1. Yes, in the station. Describe question you will propose to students to assist them in thinking about the effect of multiplying by the matrix. I think it describes the reflection over itself of the triangle. It reflected by itself, and it's easy to understand. Question 24. Describe other questions you could pose to students to assist them thinking about the type of reflection that is represented by the matrices in the item B to D in question 22. I may ask students which equation can be the representation for D by matrices D. The answer should be x equals minus y. Question 25. Measure the chord. It wants me to open swimmer dancer. Swimmer rotation. First of all, yay. Measure the coordinates of A üssü, B üssü, and C üssü. Describe how the coordinates of point A üssü, B üssü, and C üssü are related to the coordinates of points A, B, C. Actually, it must be there's a steps. Let's make these steps together. Click on the point at the original and choose mark center. Click on the point at the origin and choose mark center. There's an origin and as a mark center. Yay. Yes. And then go to the transform menu and select the objects you wish to rotate. Select the object. Yes, wish to rotate, and then rotate 90 degree. Rotate 90 degree. Yay, I got it. Another stick figure, which is by rotating. And then A üssü, C üssü, and B üssü. Let's find the coordinates of them. Yes, C üssü, A üssü, and B üssü. Yes, I found it, also the coordinates, as you see that. Question 26. Rotate the image stick figure about the origin through the angle of 90 degrees. How are the coordinates A üssü üssü, B üssü üssü, C üssü üssü related to the coordinates of the points A, B, C? How are the connections of A üssü üssü, B üssü üssü, and C üssü üssü related to the coordinates of points A üssü, B üssü, and C üssü? Are either of these relationships the same as reflection described in question 25? Explain why they might be the same or different. And it wants me again made as a center, and then rotate again 90 degree. Yes, I got it. Another one. Let's make it bigger. And it wants me to üssü üssü, great, C üssü üssü, and D, B üssü üssü, and find the coordinates of them. Anyway, coordinate, and yes, A üssü, C üssü üssü, and B üssü üssü. Actually, A, B, C are related to the points A üssü üssü, B üssü üssü, and C üssü üssü. This stick figure. A, B, C are the reflection of this one. The coordinates are in the screen. It's not the same relationship the points A, B, C have with the A üssü, B üssü, and C üssü points. A üssü üssü, B üssü üssü, and C üssü üssü are also reflection points. However, A üssü, B üssü, and C üssü, they are rotation. And we call it as a reflection also. This one. A, B, C. If I reflect A, B, C, I'm gonna get this stick figure. But this is rotation, this is reflection. Question 27. Predict what the coordinates will be if the stick figures containing A üssü, B üssü, and C üssü is rotated about the origin through an angle of 90 degrees. Use your DGE to try it out. Was your prediction is correct? And I've already found all the points. No need to answer it. Question 28. Describe a rule that you could apply to coordinates of points A, B, C. For example, that would result to coordinates or the corresponding image points. Let's look at my answer for it. Also, I can say it. Look at the point A. 7, 4. All these are positive. 7, 4. And it changed the way. And 4 goes for x-axis with minus, and 7 goes for y-axis as a positive. And the rule can be, question 28. I can say the rules x, y goes minus y to x. Question 29. Describe a rule what you could apply to the coordinates of points A üssü, B üssü, and C üssü that would result the coordinates of the corresponding image point. What do you notice about the rule, and the rule you develop is question 28. And also it can be x, y goes y minus x if the rotation goes clockwise, which is A goes A üssü üssü. Question 31. Rotate the points A, B, C and about the origin through an angle of 30 degrees. Is there a rule that you could use to describe the relationship between a point and its corresponding image under the rotation? And I already rotated. Also, I can rotate again. And rotate as a 30 degree. and I got another one, but I couldn't predict the rule of rotation for it. Question 33. Describe other activities that you would want to engage with your students using the thermal rotation sketch. Explain how these activities would assist students in understanding the properties of rotation. I would ask the students rotate 180 degrees with using the thermal rotation GCP. And then I want them to find a rule for it. I will assist for students if they understand what they do while rotating a 90 degree. Question 33. Question 33. Use the equation for x üssü and y üssü to write a matrix that can be used to represent a rotation about the origin through an angle Q. I need to let's open a new sketch and then make a grab, and I can do that point and then find the coordinates. Let's label as a B or A, it doesn't matter, and then A, find the coordinates of it. I need the rotation with it as a 190 degree from the rotate 190 degree. Yes, I got it. Another point as a üssü, and let's find the coordinates of it. And also there's another way to find by matrices. The rule is cosinus 180. This one I just need to write a degree in this one, and then these are my points, and yes, I got and I can make it for these points. It's gonna be clear. Let's snap plot points 2.05 to 1.94. This is my point, and label it with BC, find the coordinates, yes, and then translate it. Rotate as a 90 degree, and this is my point C, and let's find the coordinates. After these matrices, I made the equation. Yes, as you see that I got the same answers after rotation. Let's go to another question. Question 34. Show how the matrix you created in question 33 can be used to find the coordinates of the image of a point A, which has coordinates -1, 4, under a rotation about the origin through of the angle of 45 degrees. What's my rotation matrices? Actually, it will be better to open, don't say. There must be another sketch. Rotation matrices. Yes. If I write there 180, what about the 45 degree. After 45 degree, where is my point? My 1 minus 1. Let's go my point as a minus 1 to 4. Minus 1 to 4. Or I can write as a minus 1. Can I change it? What about this one? No, I just write it minus 1 to 4. Yeah, great. Minus 1 to 4. This is my point C, and it goes minus 3 to 5, and the point B. Yes, it goes after rotation by 45 degree. It goes to point ABC, which is minus 3, 5 to point 1. Question 35. Open the sketch rotation matrices. You'll see that but you can enter new values for the degree measure of the angle of rotation. Design question that you could pose to students while using this sketch. I want to ask the students to try this equation with in a different angles, such as 270 degree or for the others angles. Question 36. Are there any changes to modification you would make to the sketch? Explain how these changes are related to learning goals you have for students. I think we can change points of the shape, then rotate again, and then find the new results. The other modifications can be finding the rotation with the clockwise. So far, the way was the counterclockwise. We can change it. The matrix will change too. Question 37. Drag various objects in the sketch and notice how they affect triangle AC, BC, and CC. In general, do what single geometric transformation is the composition of two translations equivalent? Will this always be true? Explain. Actually there is some rules first of all for this compositions, such as, let's open a new file, and then it wants me create a triangle, and then label it with A, B, C, and also made a line as a DE, label DE and FG. It wants me first of all translate triangles UBC using a DE, label the image AC, BC, and CC. Yes, first of all, as a mark center, I need to make it first of all mark vector, and then pick my triangle, and then translate. Yes, why I got it? It wants me. Sorry, I forgot to pick the point C, and then no, translate it. Yes, after I got it, pick this one as a vector, and then choose this triangle with all these points and then translate it. Yeah, actually if I made it like this, make it small, yes, it will be better. It means A üssü, B üssü, make it, and A üssü, B üssü, and D üssü. Yes, it wants me the question 7. Drag the various objects in the sketch and notice how they affect triangle A üssü, B üssü, and C üssü. In general, to what single geometric transformation in the composition of two translation equivalent? Will this always be true? Explain. I drag a point on the triangle ABC. It does not change anything on the other triangle. On the other hand, when I move the triangle ABC, I then realize that all the triangles are moving. Look at this one. Yes, all these are moving. All of them are connecting with each other. Also, the first translation is the triangle A üssü, B üssü, C üssü. The second composition translation, if the triangle is A üssü, B üssü, C üssü, are not equivalent. In some situation can be true, but we don't make a generalization. Question 38. How is the vector for the composition of two translations related to the vectors specified for the first and second translation? The first translation was by vector DE, then what I got the triangle, this one, and then I translated the this triangle by the line of FG. Each translation has a connection with each other because it's a composition. Question 39. If you translate by vector A and then translate using vector B, is that the same as translating by vector B and then translating using vector A? Provide an explanation that involves the use of matrix representation. Actually, we can call it vector A and also this one can be vector B. Yes, what was it before I did? First of all, I made a translation by DE, and then what I got it, this one, and then I made a translation by the vector B. I'm gonna do the other way. For example, let's pick this one as a vector, firstly as a vector, and then translate it. Yes, I got this one, and then I'm gonna pick this line as a vector, and then what I got it, not this one, it will be better to make a separate, then translate it. Yes, yay, again I got the same thing, made it again, and then translate DUE. Yay, I got the same things. And what does it mean? The compositions of the results are equivalent. Question 40. Leave the video clip. Anyway, past this question. I don't know, I don't have a video clip, that's why. Question 41. Question 41. In general, what single geometric transformation is equivalent to the composition of two rotations about the same center of rotation? Will this always